Hey you, yeah, you. We're going to be talking about experimental designs and all the different ways you can conduct an experimental design. Are you ready? Great, let's get started. So, what are experimental designs? Let's break it down. Experimental has the root word experiment. An experiment is a procedure done to make a discovery, and design is a way to carry out something. So, putting those two words together, an experimental design is a process of planning an experiment that meets specific goals. Experimental designs are essential for research designs and confirming validity. Validity is the accuracy or correctness of research. Research designs are an overall plan for a study, including the collection, measurement, and analysis of data. There are three main types of experimental designs: true experimental designs, quasi-experimental designs, and pre-experimental designs. Let's take a look at each one. Our first design is a true experimental design. They are characterized by 1. Random assignments, 2. Treatment groups, and 3. Control groups. Random assignment means that each individual in the experiment has an equal probability of being chosen and an equal probability of being assigned to any of the treatment groups in an experiment. There are two groups in a true experimental design: an experimental group receiving the treatment and a control group that is not exposed to the treatment. There are three main types of true experimental designs: the classic experimental design, the post-test only control group design, and the Solomon four-group design. But before we take a look at those, we must understand E, O, X, and the numbers 1 and 2. E stands for equivalence, meaning the experimental and control groups being compared to each other are as similar as possible. O stands for observation. This is where data is recorded about how the group is responding at the time. X stands for the treatment that is being given, and the numbers 1 and 2 represent the number of times that the observation has been made. Let's start with the classic experimental design. This design has one experimental treatment group and one control group. They both undergo randomization and equivalency. Then the first observation is recorded. After this, the treatment is given, and then the groups are observed for a second time. Any differences between them would be assumed to have been produced by the treatment or lack of treatment. Moving on to the post-test only control group design, we can see that it has one experimental treatment group and one control group. They both undergo randomization and equivalency. Then the treatment is given, and the groups are observed for the first time. Any differences between them would be assumed to have been produced by the treatment or lack of treatment. It is called post-test only because the observation only occurs after or post the treatment. Lastly, the Solomon four-group design is the purest of true experimental research designs. It combines the classic experimental design with the post-test only control group design. The Solomon design has 4 groups, the first 2 resembling a classic design and the last 2 resembling the post-test only control group design. After all the observation and treatments, the data can be analyzed. Our second design is quasi-experimental designs. They do not use random assignment of groups and instead employ matching or other means of obtaining equivalence of groups. Matching is having equivalence by selecting individuals who match certain characteristics, such as sex, age, and race. There's usually just one group in quasi-experimental design, which would be the experimental group receiving the treatment. However, in some cases, there can be a control group that is not exposed to the treatment. There are 2 main types of quasi-experimental design: time series and counterbalanced designs. As previously used, we will examine these designs using E, O, X, and the numbers 1 through 4. Let's compare and contrast time series and counterbalanced designs. Interrupted time series has one experimental group that undergoes equivalence by matching characteristics. Then over a predetermined time span, whether that is a week, month, year, etc., several observations are recorded equally across the time span. After however many observations, the treatment is given, and then the groups are observed for the same number of times over the same amount of time. For example, if we observe the group 4 times over 4 months, give them the treatment, we will then observe them another 4 times over the following 4 months. The second type of quasi-experimental design is counterbalanced design. A counterbalanced design has multiple experimental groups receiving different types of treatments at different times over a certain time period. They are also observed after each treatment. As you can see in the diagram, each group receives all 4 treatments, but the order they receive the treatment varies. Our third and final experimental design is pre-experimental designs. The 3 major elements of an experimental design are equivalence, experimental group, and a control group. We have seen these 3 elements in the last few slides. However, pre-experimental designs either lack 1, 2, or all 3 major elements. They also do not use random assignment. There are 3 main types of pre-experimental designs, both 1 and 2 group ex post facto, and 1 group before and after design. Once again, we will be utilizing E, O, X, and the numbers 1 and 2. Let's start with the 1 and 2 group ex post facto design. Both of these usually lack equivalence. The treatment is given and then the groups are observed. As you can see, the 2 group ex post facto design has a control group. Lastly, with the 1 group before and after design, it is similar to a true experimental design. The first observation is recorded and then the treatment is given. After this, the groups are observed for a second time. Despite this, it lacks random assignment and usually equivalence, and it does not have a control group. Wow, we just went through all 3 types of experimental designs: true experiment designs, quasi-experimental designs, and pre-experimental designs. Now that you know all the different types of experimental designs, you should be ready to answer any experimental design question. I hope you enjoyed this video. Here are some funny GIFs.